Download this code from codegive.com, link in the description below. OK, let's dive into the concept of but what is the question, often used in coding and software development, along with explanations, examples, and code illustrations. Understanding but what is the question. But what is the question is a critical thought process used when you're faced with a problem, a task, a requirement, or a seemingly vague instruction. It's about clarifying the real objective, digging beneath the surface to understand the core problem you're trying to solve. It's about defining the goal before jumping into implementation. Often, especially in complex projects, the initial problem statement or request might be incomplete, ambiguous, or focused on a particular solution rather than the underlying need. This can lead to wasted effort building the wrong thing, solving the wrong problem, or creating a system that doesn't actually address the user's needs. Why is it important? Preventing wasted effort. Spending time building the wrong feature or solving the wrong problem is costly. Clarifying the objective early on saves time, resources, and frustration. Ensuring correct solution. By understanding the true need, you can design and implement a solution that effectively addresses the underlying problem. Identifying edge cases. Asking but what is the question helps uncover edge cases and unexpected scenarios that might not be immediately apparent. Improved communication. It facilitates better communication between developers, stakeholders, and users, ensuring everyone is on the same page. Fosters innovation. By challenging assumptions and exploring alternative solutions, you open the door to innovative approaches. When to ask but what is the question? Vague requirements. When you receive a task or requirement that's unclear or open to interpretation. Predefined solutions. When the request focuses on a specific solution without explaining the underlying problem, example, we need to use a specific database. Changing requirements. When the requirements change or evolve, especially if the change seems arbitrary. Performance issues. When encountering performance bottlenecks or scalability problems, before jumping to code optimizations, understand the expected load and usage patterns. Bug reports. Before fixing a bug, understand why it's happening and the specific user impact. Feature requests. Before implementing a new feature, understand why the user wants it and what problem it solves. Legacy code. When dealing with legacy code, try to understand the original purpose of the code before refactoring or making changes. When a problem seems to have an obvious solution. Sometimes, the obvious solution is not the best or the most appropriate one. Asking but what is the question can help you find a better solution. How to apply but what is the question? 1. Actively listen and read carefully. Pay close attention to the problem statement, requirements, or requests. 2. Identify assumptions. Look for any underlying assumptions that might be driving the request. 3. Ask clarifying questions. Don't hesitate to ask questions to clarify ambiguities, uncover the user's intent, and understand the context. Here are some useful questions. What problem are we trying to solve? What are the goals of this feature/change? Who are the users of this system, and what are their needs? What are the expected inputs and outputs? What are the success criteria? What are the potential edge cases? What is the expected load/scale of this feature/system? What are the security considerations? Why this particular solution? Is there a specific deadline or budget constraint? 4. Challenge assumptions. Don't be afraid to challenge assumptions that might be incorrect or limiting. 5. Define the problem clearly. Once you have a clear understanding of the underlying problem, define it precisely. 6. Explore alternative solutions. Don't get fixated on the first solution that comes to mind. Explore alternative approaches that might be more efficient, elegant, or effective. 7. Validate your understanding. Before starting implementation, validate your understanding with the stakeholders or users. Confirm that you're solving the right problem and that your proposed solution meets their needs. Examples with code. Let's illustrate this with a few code examples. Example 1, we need to implement a rate limiter. Initial problem statement. We need to implement a rate limiter for our API. But what is the question? Clarifying questions. Why do we need a rate limiter? To prevent abuse, protect against DDoS attacks, manage server load. What is the acceptable rate limit? Requests per second/minute/hour. What should happen when the rate limit is exceeded? Return an error, queue requests, drop requests. Which APIs need rate limiting? Does the rate limit apply to individual users, IP addresses, or the entire API? Do we need to persist rate limit information, example for long-term blocking? Underlying problem. Protect the API from abuse and prevent server overload. Ensure fair usage among users. Solution considerations. Based on the answers to the clarifying questions, you might choose from different rate limiting algorithms, example token bucket, leaky bucket, fixed window, sliding window. You might use an in-memory store, like Redis or MEMC8, for speed, or a persistent database for longer-term blocking. Code example, Python with Redis, token bucket. Explanation of the code. Redis uses Redis as a fast, in-memory data store to track the number of tokens remaining for each user. Token bucket algorithm. The rate limiter class implements a token bucket algorithm. Each user starts with a bucket of tokens. Each request consumes a token. Tokens are replenished at a fixed rate. If a user's bucket is empty, the request is blocked. Lua script. Uses a Lua script for atomic operations in Redis. This is crucial for concurrency. It prevents race conditions where multiple requests might try to decrement the token count simultaneously. The Lua script fetches the current number of tokens for the user, calculates how many tokens should have been replenished since the last request, and decrements the token count if there are enough tokens. *is_allowed, method *the is_allowed, method checks if a request from a given user is allowed based on the rate limit. Without asking but what is the question? You might simply implement any rate limiter, potentially choosing the wrong algorithm, the wrong storage mechanism, or the wrong rate limit values, leading to a system that's either ineffective, easy to abuse, or overly restrictive, impacting legitimate users. Example 2, add a download PDF button to the page. Initial problem statement. Add a download PDF button to the page. But what is the question? Clarifying questions. What is the source of the PDF? Is it a pre-existing file, or does it need to be generated dynamically? What data should be included in the PDF? Who should be able to download the PDF? Everyone, logged in users, specific roles. What should the PDF look like? Layout, styling, branding. Where should the PDF be stored, if generated? Temporarily or permanently? Should the PDF be generated on the client side or server side? Asterisk how large are we expecting the PDFs to be? Asterisk underlying problem asterisk users need to be able to easily save the data displayed on the page as a PDF document. Asterisk solution considerations asterisk. Asterisk pre-existing PDF asterisk if the PDF is a static file, the button simply needs to link to the file. Asterisk dynamic PDF generation. Client-side libraries like JSPDF or HTML2 PDF.js can generate PDFs directly in the browser. This is suitable for simple PDFs with limited data. Asterisk dynamic PDF generation. Server-side if the PDF requires complex formatting, data from multiple sources, or access to server-side resources, generating the PDF on the server is the better approach. Libraries like ReportLab, Python, PDFKit, Node.js, or iText, Java, can be used. Asterisk security asterisk if the PDF contains sensitive information, ensure that access is properly controlled. Asterisk code example, client-side with HTML2 PDF.js. Explanation of the code asterisk. Asterisk HTML2 PDF.js library asterisk the code uses the HTML2 PDF.js library to convert the content of the content to PDF div into a PDF. Asterisk add event listener asterisk an event listener is attached to the download PDF button. Asterisk HTML2 PDF dot from element dot save asterisk when the button is clicked, the HTML2 PDF dot from element dot save function is called to generate and download the PDF. Asterisk simple example asterisk this is a very basic example. HTML2 PDF.js offers more advanced options for customizing the PDF's layout and styling. Asterisk code example, server-side, Python with ReportLab. Explanation of the code asterisk. Asterisk ReportLab library asterisk uses the ReportLab library to create the PDF. Asterisk generate underscore PDF. Function asterisk this function creates a PDF file with the given data. It sets up the canvas, adds text, and saves the file. Asterisk Flask integration asterisk this example uses the Flask web framework. Asterisk at approot, /download underscore report, asterisk this defines a route that triggers the PDF generation and sends the PDF as a download. Asterisk send underscore file, asterisk the send underscore file function sends the generated PDF to the user's browser as an attachment. Without asking but what is the question? You might implement a client-side PDF generation solution that works fine for simple data but breaks down when the data becomes complex or requires server-side access. Or you might implement a server-side solution that's overkill for a simple PDF. Example 3. The system is running slow. Asterisk initial problem statement asterisk the system is running slow. Asterisk but what is the question? Clarifying questions. Asterisk when did the slowdown start? After a recent update, during peak hours. Asterisk which parts of the system are slow? Specific pages, specific functions, the entire system. Asterisk who is experiencing the slowdown? All users, specific users, users in a specific location. Asterisk what is the expected performance level? What is considered slow compared to what is expected? Asterisk what are the server resource utilization levels, CPU, memory, disk I/O, network? Are there any spikes? Asterisk have there been any recent changes to the code or configuration? Asterisk how many users are active during the slowdown? Asterisk are there any long-running queries or processes? Asterisk are there any error logs or exceptions? Asterisk have we checked for slow database queries? Underlying problem the system is not meeting performance expectations, impacting user experience and potentially leading to business losses. Solution considerations the answers to the clarifying questions will guide the investigation and solution. Possible causes and solutions include database performance slow queries, missing indexes, database connection issues. Code inefficiency inefficient algorithms, memory leaks, blocking I/O operations. Server resource constraints insufficient CPU, memory, disk space, or network bandwidth. Network issues high latency, packet loss. External dependencies slow response times from external APIs or services. Caching issues inefficient caching or invalid cache configuration. Too many concurrent users, scale up the server. Code example, Python, profiling slow code. Explanation C profile the C profile module is used to profile the code. It collects data about how long each function takes to execute. C profile.run, this function runs the code and saves the profiling results to a file, profile_output. pstats the pstats module is used to analyze the profiling results. p.sort_stats, cumulative, this sorts the profiling results by cumulative time, the total time spent in a function and all its subfunctions. p.print_stats, 20, this prints the top 20 functions that took the most time. Without asking but what is the question? You might start optimizing code randomly without knowing which parts of the system are actually causing the slowdown. This can lead to a lot of wasted effort and minimal performance gains. Key takeaways. But what is the question, is a mindset. It's about digging deep to understand the true underlying problem. It's a continuous process, not a one-time event. You might need to ask clarifying questions repeatedly as your understanding evolves. It's essential for effective problem solving, communication, and innovation. It prevents you from wasting time on the wrong solutions. By adopting this approach, you can become a more effective and valuable software developer, capable of delivering solutions that truly meet user needs and solve real-world problems. Remember to always question assumptions, clarify requirements, and focus on the core objective before diving into implementation.